Right, as you can see, laid out on the bench, we have the vast majority of the components for the X-axis, with the notable omission of the X-axis lead screw, which is actually sitting on the machine table. I've also got this bracket here, which is the keep for the non-handle end, if you like, the bearing end. So we've got the main keep, which has the mechanism for the handle and the engagement device for the power feed, and we've got this one as well. So we'll get over to the machine now. We'll have a look at the lead screw, we'll lube it up, and we'll run it through the nut in the power feed gearbox. So there we are, there's the X-axis lead screw sitting on the table, and it is in the correct orientation, so end for end where it fits. And I've shown you this before, but I'll show you it again because it was quite some time ago. We've been playing around with gas turbines. There is the X-axis lead nut in the gearbox. So that's where the screw threads through and passes out of the opposite end at the other end of the table. So at this end, we've got some holes here for dowels to fit, and then 4 bolt holes, 4 tapped, quarter UNC for the main keep to go on. And then at the opposite end, we have, again, we've got some locating holes for dowels and some bolt holes as well for the ubiquitous quarter UNC. And this is the end that has the thrust washers, thrust bearings even. So the idea of this trial assembly, as I said at the beginning, is to actually give us some idea of what we can do in terms of making a shoulder for this end of the lead screw, so that we don't get the issue with the bearings where they suffer that that kind of false Brinelling that was caused by the bearing race not sitting correctly. It was actually sitting in this groove, a run-out groove for the thread, so really not very good design. So we're going to try and see if we can make good on that. I should note that these components, with the exception of the far end keep, they have been cleaned up and degreased and had the paint taken off them, but not yet to the standard that I want for them to be at before I paint. The bracket, for example, has still got some grey on there, so that still needs to be treated further to get rid of all that paint. These components have all been cleaned and degreased, but they're still not yet at the standard I want them to be at. They're good enough to go together for this trial assembly, but they're going to need a little bit more effort. Here is the handle that I sent to my brother Dean at Retro Mechanica. He straightened that for me very, very nicely indeed. And that hand wheel fits, or that handle rather, fits into the hand wheel, into that hole there. So you'll see it all together shortly. So we'll get on with lubing up and fitting the lead screw into the power feed gearbox. So I have almost inevitably hit upon a snag before I even start, and that is one that is kind of, well, it's going to happen in a workshop with very little space, where you have to make the most of every little inch, and that is that there isn't enough room between the end of the table and the far wall that's behind you there for me to get the lead screw in this way. So I'm going to have to put the wheels on the rails and rotate the machine around 90, so it's facing towards the lathe, or so that the business end is facing towards the lathe. So we'll do that now. Right, so as per usual, fitting those moving beams was an absolute nightmare. I think what I'm going to do for future use is put studs on the side of the machine so that the beams slide over the studs and they locate them in position without having to try and put bolts in there whilst clamping or holding the beams in place, because they are incredibly heavy. I made them to take it off a pallet when it was fully laden. In other words, it was all built up. So that's why I made them a lot stronger than they needed to be, and also so that they could go over, you know, projected rough terrain and I don't know. I think I probably just made them too strong. But they're unwieldy. But anyway, let's get it shifted now. We're going to spin it round through 90. So it ends up facing, I've got my back to you, so it ends up facing towards the lathe. The business end ends up facing towards the lathe. But I need to make sure that I've still got enough room at the back to get in with the motor when the time comes. Right. I think that'll be enough. Let's get this vacuum cleaner out of the way. I am, of course, very cognizant of the fact that I'm going to try and get the core of the turbine in here as well. Perhaps I've bitten off more than I can chew. We'll find out, but I think, right, that gives me access to the back. It still allows me to open the drawers for the tools. I can still use the lathe. Yeah, it's not brilliant, but it's better than not being able to use the lathe. And I've got a bit more space down here now where I can put the engine. Potentially. It might still stay at the museum, but anyway, I'll get it off these pesky wheels and I'll bring you back. Right, we've got the machine shifted. I've lubed up the nut and I've lubed up the screw. So let's go for it. Let's get this through. I'm putting it in first of all, and then I'm going to mount the keeps afterwards. That's going in nicely. There's little to no play on that, but I knew that there wasn't from before when I took it off. Tell you what I could do actually, I could put this on the end of it and then I could actually wind it in with the handle, couldn't I? Don't want to bend it, but that's something else we need to check as well, isn't it? The bend. But let's do this first. Actually, that's making it easier to turn, just having the key portion on it. I'll carry on threading this in and I'll bring you back once it's in. Right then, so to assemble the first keep, we have the inner sleeve, which has an inner fine spline and an outer coarse spline. We slide the outer sleeve with an inner coarse spline over the top of that. Sorry, this way. So it slides like this. And then we put the chapter ring over the outer sleeve. So that's now ready to go onto the lead screw. What I've done ahead of time here is I have pre-assembled the fixed dogs, or the fixed spline portion, onto the keep on the dowels with the 2/4 UNC bolts holding it in position. So now we'll move over to the machine and we'll fit this keep bracket onto the end of the table. Right, so we can slide the keep over the lead screw, over the spline portion and the plane portion. I don't know if I showed you actually when I was at the bench, but I've also fitted the phosphor bronze bush in the keep as well. See that there? Right, so that slides over the lead screw, over the plane portion, which is the bearing, in the board in the phosphor bronze bush. We'll slide the dowels into position and give it a tap. Right, that's that home and in position. Get the bolts in it. We'll just put 2 bolts in for now. So these are 5/16 UNC. Put them kind of diametrically opposite. Right, that's that on. So let's have a look underneath. Right, so I've got a light shining under there. What I'm hopefully showing you, and I hope you can see, is that the plain portion of the lead screw is flush with the bronze bush. And hopefully you can see as well, I'm just going to zoom in a little bit. There is a little bit of leeway there for us to run that in and out, which should hopefully help to give us a bit of clearance at the opposite end, so we can get a nice distance piece on there for to back the bearings up. So before I assemble the handle mechanism or the hand wheel mechanism, I thought I'd show you how the lead screw is locked up so that the power feed can work. So under normal or under hand feed circumstances, I should say, this assembly here forms a dog clutch. So when that's slid back, then the dog clutch is disengaged. But when you operate this thumb screw, which I'll show you now, this one here, which goes onto that 1/2 inch UNC thread there, you tighten that into there, so the sleeve slides into the teeth there on the fixed portion, and that forms a dog clutch, which is then locked the lead screw to this portion. So the lead screw can't rotate anymore. So when the nut turns underneath here, which you can see there, then the lead screw moves along as the nut turns. And then when you want to use hand feed again, you unscrew that thumb screw, this portion slides back, and then you can rotate the screw, and that moves the whole table through the nut. So we'll get on now, we'll get this assembled, and we'll have a look at what gaps we've got at the other end. Right, the trial assembly is complete now, and as you can see, the table's moving nice and smoothly under hand cranked power. However, if you go back to Harrison Mill Resto 19, when I was talking about the lead screw perhaps having a bit of a bend in it or a bow, and the issue with the false Brunelling on the bearings, I think we have got an issue something like the type of thing that I was talking about in that video, and I'll show you that now. So looking at the inner thrust bearing on the back of the keep there, you can see that the issue that I spoke about in Harrison Mill Resto 19 does appear to come into play, in that we don't have any kind of a shoulder here to back up this outer race. It's just literally the thread is bearing against it, and that means that this outer race is not loaded circumferentially in an even way. So most of the load is on one side of the bearing, where that half of the thread is actually pressing against it, because at this end we've got a nut which gives us some preload on the other bearing. So that's giving us this preload here, which is pressing against this side of the bearing more than it is on this side of the bearing. And I'm just going to show you some film now that I made to see if there was any nutation in this bearing assembly when the screw rotates. There doesn't appear to be any discernible nutation, but I'll bring you back in a minute after you've seen that part of the film, which will actually show you in much more detail and a much clearer way what I'm talking about with regards to the way this bearing is loaded asymmetrically. So now you've seen that bit of film, I'll just show you this. So I've got this feeler gauge set up to 0.7 mil, and what I'm talking about with this bearing does seem to be borne out by measurement, and I'll show you that now. So I can get this 0.7 of a mil feeler in at the top quite easily, and I would say that is 0.7 of a mil there. But at the bottom, and it doesn't show up very well on the camera, but you can see it's a much harder push to get it in. It will go in, but I've really got to push it, and you can see it doesn't quite want to go, whereas at the top it slides in quite nicely. So there is definitely more pressure on this side of the race than there is at the top, or asymmetrically. So 180 degrees apart from one another, there is a slightly different gap, which indicates that there's slightly different pressure on this race. So we're going to have to do something about that, in my opinion. I mean, it lasted 50 years, don't get me wrong, and we could probably leave it like this and it would be okay, but I know about it, so I have to do something about it. And that probably means turning some of this thread back and putting some kind of a sleeve on here with a flat face that can bear against this this race in a more even fashion. So that's the end of the video. It's a fairly short one this time on the mill. So that shows you the problem that I've got with the X-axis lead screw. It's not a massive problem, I'll grant you that. However, it is something that needs to be addressed. Now, I don't know when I'm going to address that. Should I address it now, or should I just keep the momentum moving forward with the mill reassembly and address it at some future date? Because, as I said before, it has lasted for 50 years. And the slight bow or bend that I thought there was in the lead screw, it doesn't seem to be apparent when it's assembled. There's no kind of hint of nutation, there's no feel of the screw stiffening up and going slack again as you turn it. So I think from that side of things, I think my initial thoughts were that when it's in its keep at either end and it's held the way it's supposed to be in the correct orientation, it should be okay, and I think it will be. But I need to make a decision. Am I going to continue with the reassembly, or am I going to do something about this now and then move forward? I'm not quite sure, because I'm very mindful of the fact that I've got the turbine coming in here probably early next week. It's Saturday today, so we're looking at Monday to get the turbine in here, or at least, you know, the core of it anyway. So yeah, I have to make a decision. I'll let you know as soon as I've done so. But thank you for watching my film. I really appreciate your support. And if you're not subscribed to my channel, please do so. I'd love to have you along for the mill, for the turbine, and for everything else that we do in here. That would be great. And please give me a like as well. That always helps to move things along and to get the old YouTube algorithm pushing me into the right places for the channel to grow. So yeah, that's always good. Give me that thumbs up. Okay, take care of yourselves, and I will see you next time.